and get started. So I'm Logan Ward, another member of the Globus Labs team and an assistant scientist at Oregon National Lab. Today I'll be talking through some of the work we've been doing on developing Colmena, a software designed for steering computational campaigns. And I'm going to particularly dig into how we've extended it to be able to run across multiple sites. So this is the work of very many people on the project. I'll give you the full list later at the end, but let's jump in to keep this in the lightning talk realm. So to motivate Colmena, we'll talk about a type of application that many of you in the workshop have probably written before, some kind of parallel optimizer. And this simple example shows really the complexity that comes into play when devising computational campaigns that need to run many different tasks in parallel. For example, I can implement my parallel optimizer using a batch strategy where I block until all members of a set of tasks complete, which of course has problems with system utilization. Or I could, on the other end of the spectrum, implement a strategy where I run my selection ahead of time and I keep a cache going of potential simulations to start next, which means I'm spending a lot of time running selection tasks, but I'm keeping the supercomputer overall more busy. And these three examples here are far from the only strategies one could think up for developing a parallel optimizer. And we created Colmena to try to make building those kind of strategies simple. Colmena itself is a Python library that sits on top of workflow engines, Parcel, FuncX, and soon to be few others. And how you build one of these strategies is you write a set of different interacting agents as Python functions that run as independent threads and communicate with a task server that is backed by a workflow engine, which completes the tasks that are asked by the thinker and sends them back as results to be processed and then used to dream up what task to run next. And what we've been able to create with Colmena are a series of tasks or a series of example applications where you can coordinate many different kinds of calculations occurring on a supercomputer. The example I show up top illustrates how we can have 6 of these different policy agents that coordinate an active learning workflow. For example, I have agents whose job is purely to read the next molecule off of a simulation queue, and when resources are available, submit it to the supercomputer. That's paired with another agent that's only responsible for storing completed results to a database. And you can take these simple sets of instructions and build them up into an application that has some pretty useful emergent behavior. For example, this application I'm showing here and is described in our ML for HPC paper from last year switches a supercomputer between simulation tasks, yellow, to model training when enough data has been accumulated, blue, to model inference in red, such that over the course of time, you can gradually retrain these machine learning models and, as we're able to demonstrate, find more molecules given the same supercomputing allocation than a strategy that relied on a static allocation of nodes. So hopefully this gives us some motivation for devising more of these kind of implementing strategies and fleshing out how to build them using Colmena. Now, that's Colmena in a nutshell. The rest of the talk that I want to give today focuses in on what we've done in the past year on implementing multi-site workflows. So we want multi-site workflows for some of our example applications because some compute doesn't work well on conventional hardware. Going back to that example of active learning, the CPU tasks, or the simulation tasks that is, work best on CPUs. Especially when I can get a lot of CPU nodes like this data supercomputer. The retraining tasks, however, are awfully slow on CPU and would be better if we could offload them to, say, data GPU or another GPU cluster. And we've been able to find somewhat anecdotally that by offloading these tasks onto another resource, we can shorten the make span of picking our next set of simulations and get even better improvements for our scientific workflow. So the way that we've done this, spoiler, is FuncX. As Greg illustrated in the last talk, we built a system that uses FuncX to dispatch tasks from the task server, but directly transmits data from the steering process to the workers to bypass the overhead of sending large task objects through Proxies store. And what we were able to find is that in producing, using this off, kind of out of workflow engine way of transmitting data, we can create a system that uses Globus to transfer data between systems and uses FuncX to transfer task requests that's only 3% slower on performing those machine learning tasks than if we had a solution that relied on Parcel and using Redis to transmit the data and doing a lot of wrangling with SSH ports. So in short, we can get near performance parity. For reference, this plot here is showing the make span of that machine learning task, and we can see it's about 3% longer when using FuncX, and also a measure of how well we keep the workers on that machine learning busy. Only a slight delay for FuncX. What I'm showing on the right is that that 3% difference doesn't really matter. The amount of time that I expend on a work of performing simulation tasks to the number of molecules I find is practically the same between those two examples. So no SSH tunnels, same science, much fewer headaches. We can also do some clever things with Colmena, like coordinate when and where we submit these different types of tasks, allowing us to trade off between, say, how long a scientist waits, how many CPU resources they expend, how much GPU. And that, to us, really kind of motivates our research in coming up with these more clever steering strategies. So I'm at the end of my 7 minutes. I explained to you what Colmena is and how we've extended it to do multi-site. In the next year, we're hoping to kind of build more perspective on how Colmena complements other simulation steering tools and building up more applications. And if that notion of complementing really strikes your interest, Jean-Luc and I and many others are part of an interest group on these ensemble steering teams. If you've got opinions that you want to share or discuss with others, please email me after the talk. As I said, this is an effort of very many people, so let any of us know if you've got questions about it, and we'll find the right person. Thanks again.
Any questions?
Yes. What thing would you like to be done in FuncX to make your work easier?
Well, that's a grand question. So being able to query for the kind of amount of resources available at an endpoint and get kind of notifications when they become available would be very useful in, say, devising a steering strategy. Like if I know I have a job waiting in queue, I might wait to submit a new simulation task or perform any other kinds of steering options. So that kind of notification about resource availability could enable some more kind of efficient steering algorithms.
Good idea. Just looking at Josh. Usable. Sure.
In the back.
Any other questions for Logan? Okay, we'll move on to the next.